All right, Geometry Geniuses, we're back with the second part of 3.1. Previously, we were talking about what kind of lines. We were working with parallel lines that look like this. We were looking at perpendicular that intersects and make what kind of angle? You should be saying 90 degrees. We also saw skew lines where they're kind of in different sections and don't correlate with each other all that well, meaning that they're non-coplanar and they're not parallel and they don't intersect. So those types of lines are definitely important. As we start to move towards angles formed by a transversal, well, what exactly is a transversal? We've seen lines intersect before, but a transversal specifically is a line that intersects two or more coplanar lines at two distinct points. I guess sometimes more, but for the scenarios we'll see, we'll only have them intersecting twice. So what we have here is line L, line M, we have transversal T. That's a very fitting way to call the line T. So what's up with this? When the transversal intersects two lines, 8 angles are created, seen here. We have 8 of them. As shown in the diagram above, many of those angles have special relationships with each other, which we will study in this unit. We'll be looking at 4. Starting with the first one, corresponding angles. These lie on the same side of the transversal, T, and in corresponding positions. So we would be looking at angles that are on the same side of the transversal but in different spots. You can kind of think of this as these are 4 angles, their own little hub or click, and these are an additional 4 angles in their own little hub or click. So we would be saying that the angle in the top left, let's say angle 1, is corresponding with angle 5 because they're both on the same side of the transversal and they're in corresponding positions. So 1 and 5 is an example. We could also use 4 and 8 because those are on the bottom left. We could also use 2 and 6, also 3 and 7. And those are all considered corresponding angles. So you may want to take this time now, pause it, get the definition down, get the examples written, and then we'll continue to alternate interior angles, which are non-adjacent interior angles that lie on opposite sides, so that's important, opposite sides of the transversal. So we are looking at opposites. So non-adjacent, and this is kind of like vertical angles where, or no, not quite vertical angles. So opposite sides of the transversal, we see that 4 could match up with 6 because these are kind of opposite each other, hence the opposite. That's what I underlined. So 4 and 6 could definitely work along with 3 and 5. 3 and 5 meaning opposite right there. Cool. We could also look at same side interior, where these are interior angles that lie on the same side of the transversal. So the interior, I haven't talked about that yet. That's the space in between the two lines that the transversal creates. Think of it interior, inside, exterior is outside. We've seen this previously with the types of angles we've seen. So interior angles are on the inside, on the same side of the transversal. Well, 3 and 6 are on the same side of the transversal, so we could say that those are same side interior, along with 4 and 5. That's fair game. So we've got those 3. The 4th type of angle pair we'll see, non-adjacent exterior angles that lie on opposite sides of the transversal. So pretty much alternate exterior angles. So this is just heavily on the exteriors. So we see that we have 1, 2, 8, and 7. Those angles are on the exterior. So the alternates of them, we could say, match up. So 1 and 7 would work along with 2 and 8. So 1 and 7 are alternate exterior angles. They're opposite the transversal. They're in different sides. And that's what's up with that. And we'll see some examples of this. So we have these transversals here, taking a look at the type of example for each angle pair. So we're looking at corresponding angles. Well, I go back and I look at my information when I'm stuck. So recall that corresponding angles lie on the same side of the transversal and in corresponding positions. So corresponding angles, we could say that the top left and top left, angle 1, angle 5. They actually label these the same way, so that's totally okay. We could also say 2 and 6. You could also say 3 and 7. You could also say, what additional pair could we say? We could do angle 4 and angle 8 for sure. For alternate interior angles, so we'd just be looking at the interior now, so the inside. So again, this is the interior. So if we started with, let's say, angle 3, what's going to be the alternate interior angle for that? Should be saying 5. And we talked about that and that. We could also talk about angle 4 and angle 6. Those are good. Alternate exterior angles. So we're now on the exterior. So let's say we start at angle 2. What's going to be the alternate exterior angle for angle 2? Hopefully you're saying 8. And continuing with that, 1 and 7. Cool. Concluding with same side interior angles, we know that these have to be on the same side of the interior. So just looking at the inside, let's do angle 4. And on the same side, a little bit down farther, it's angle 5. And we could also do 3 and 6. Cool. Pretty easy section. These 4 angles happen when a transversal occurs. I think that they're pretty self-explanatory if you just think of the location, 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 location. Is it in the interior? Is it in the exterior? Or is it just corresponding where they're kind of the same direction, just different parts of where the transversal cuts? Thanks for watching. If you have any questions, bring them to class.